Jai Hind to all. Myself Dr. Neelesh Kumar Gupta. I am working as a professor at Ajay Kumar Garg Engineering College in Department of ECE. Today I will deliver my lecture on information theory. This topic I have taken from your AKTU subject, that's digital communication. Its AKTU code is KEC 601. Okay. So let's see now information theory. So I will tell you about the information theory. In communication system, what are doing? You are transferring, you are sharing, you are communicating your information from one point to another point. That's all. Only this you are doing. So you are communicating your information. Okay. So how your information, this information that I am talking here, it is in communication system. So that's I will tell you in terms of information theory. Okay. So this is the basic block diagram of digital communication system. Already I told you in my previous lectures this diagram. Okay. So this is the basic diagram of digital communication system. Okay. What happen in digital communication system? It means whenever you are communicating or you want to communicate your information digitally through the digital communication, so what will happen? So in this diagram you can see here what ki from the source your information or your information what that you want to communicate, that information goes to source encoder. Source encoder, it encodes your information along with the data compression. Okay. Then this says from this source encoder your channel encoder will be there. So from the source encoder your information, your data in terms of binary data 1010 this form, it will go to channel encoder. Channel encoder means it is accepting your digital data. Now in this digital data what? It will detect whether the error is present or not. Then because in digital communication our data is so big. Okay. So the chances of error will be more. If you are getting 1 instead of 0 and vice versa, so error will be there. So error detection correction is very important part. So after source encoding by the channel encoder, it detects the error. Then this signal goes to conventionally like modulator. Then through the transmitting antenna your signal will go through the channel. Okay, this one. Now receiving antenna, it receives your signal. Now demodulation or detection normally will be. Then channel decoder. It means now after detecting the error, if error is present, if error is not, then it's fine. If error will be there, then you have to correct that error. Then your objective will be fulfilled. Otherwise क्या होगा? You will get the error, you will get the loss, you will destruct your data. So now if the error is present, then error is corrected by channel decoder. Now it will go to source decoder, it decodes your data, your information that you encoded to the source encoder. Along the data decompression. जैसे सोर्स एनकोडर हमने डेटा एनकोड भी किया था, कंप्रेस किया था, तो अगेन यू हैव टू डिकोड योर डेटा along with the decompression, opposite of the compression. Then it will go destination and this is in the form of receiver and you will get the information. तो that जो information आपने यहाँ से भेजी है like this वही information आपको क्या मिलनी चाहिए, यहाँ पे आके मिलनी चाहिए, तभी आपका ऑब्जेक्टिव क्या होगा, पूरा होगा. So this is the simple basic block diagram of communication system. So in information theory and further coding, these blocks, these elements are the basic components of information theory and coding. So in this lecture only I will tell you, I will concentrate on information theory, not coding. Okay. Now, introduction to information theory. What is the meaning of information? What I told you, okay, in last 2 PPTs. The purpose of communication system is to carry the information bearing baseband signals from one place to another place over a communication channel. This is the purpose, this is the objective of any communication system. Information theory concerned with the fundamental limits of communication. So, information theory means it shows the fundamental limit of communication. Now, what is the information theory? So, information theory is a branch of probability theory which may be applied to the study of communication system rather channels. So, information theory is what? It is the branch of probability theory, and you are using for digital communication. So, you are carrying, you are transferring the digital information only. So, we will use only here digital channel like BSC. BSC means binary symmetric channel or binary source in terms of ones or zeros. Okay. So, information theory क्या है? It is the branch of probability theory. Okay. So, on the basis of probability theory, you can give the information theory for communication system. It is concerned, it is based on the fundamental limit of communication system. Now next question, the relationship of information theory with other field. So, it is not in, I am not saying कि perfectly it is related with a communication system. It is also related with another engineering or non-engineering fields. So, information theory is related with the communication, limits of communication theory that I told you in last PPT. It is also related with the limit theorem for large derivation like probability theory. It is also related with statistics. It is also related with economics, mathematics, computer science, physics and so on. So, this is the interdisciplinary case. So, this information theory related with all other technical and non-technical fields. Okay. Now, meaning of information. I am talking again information theory. So, at first we have to understand what is the meaning of information. Information क्या है? So, always our information of any event depends upon the probability of that event occurrence. Like, if someone says it may rain tomorrow, we will convey some information in winter season. Since raining, it is unusual event. So, in rainy season, if I am saying ki, it may rain tomorrow in rainy season. So, it is usual. We know in rainy season rain will be there. But if in the winter season I am saying it may rain tomorrow, so this is not usual. So, this is the information means whose probability is less, that is information. Usual, normalized, generalized, routine things, if it is there, so there will be no information. So, you can say information of any event, it depends upon the probability of that event occurs, and it is inversely proportional. Like one example also I will say, I want to share here. What? A dog bites a man. So, it's a usual information, not any important or anything extraordinary. But I said what? Ki a man bites a dog. So, it is not usual, non-usual. It's information. So, information related with the probability of the event, and it is inversely proportional to the probability of that event. So, information of any event ij, it is inversely proportional to what? That event probability. Okay. So, if I remove this sign proportionally and constant or any function will be there. So, if I take the function of log of function, okay, log of 1 upon p. So, this is the formula of information, and I is equal to if log m upon n. So, it will be log m minus log n. So it will be minus का log of p. Okay. So always I is equal to 0 when p is equal to 1 and it is infinite p is equal to 0. Because our information of any event is inversely proportional to probability of that event. That's why I am writing this one. So this is the formula of information. Now information unit generally we are taking in bits. You know, bits per second, how many bits? It means 8 bits, 10 bits. In the information generally we are taking the unit of information in bits. If you are taking the information unit is bits, so always you have to take base of log is 2, always, because whenever you take the log of base 10, so unit will be different. If you are taking the base of log e, so unit will be different, that will be nets or Hartley. But we are not measuring, we are generally measuring our information in bits. If you are measuring your information in bits, so you have to take log of base 2, that's you have to keep in your mind. Okay. Now next is entropy. After the information, entropy. Entropy is what? Entropy is a measure of uncertainty in a random variable. In this digital communication, we started our digital communication from random variable. In communication, nothing is certain. Okay. And generally these all the depends upon the probability, sambhavna, possibilities. And we start anything like in communication from the random variable, supposing x, y. So entropy is a measure of uncertainty in a random variable with respect to communication system. So entropy x is a measure of amount of uncertainty associated with the value of x. And this h of x, quantity h of x is called entropy of the source, our data, our information. It is measure of average information content per source symbol. So h means what? Your average total information per individual source symbol or per individual message. Okay. And its formula, if you drive it is simple. So hx is equal to minus of this p x of I into log of 2 p x of I, where I from 1 to n, bits per symbol, bits per message you can take. So this is the formula of entropy of the source in the minus sign. Why? Because log m upon n, log m minus n. If you want to get into the positive sign, so this formula will be what? Summation I1 to m p x I log of base 2 1 upon. So this is our what? Entropy of the source. So this is the formula of entropy, summation from 1 to 6, 7, 8 or the number of messages p into log of p. Okay, and base of log is always 2. अब question is that how you solve the log of base 2. So log of base 2 for x will be equal to log of 10 base x upon 0.3010 or log of base e x upon 0.693. So you can convert your log of 2 base of any value for any value. If you are calculating on the base of log 10, so you have to divide by 0.3010. If you are calculating on the base of e, so you have to divide by 0.69. This is the very important that you have to keep in your mind always. In information theory and coding, whenever you are using this entropy, information and another related formulas, you have to use what? Base of log 2 in the source coding and so on, everywhere. Now the properties of entropy. First property, hx single. If you are having single message, okay, your formula is what? H of x is equal to what? Minus summation I1 to m p x I into log of base of 2 pxi. Okay. So here, if you are having single message, if you are having single message, so probability of that single message will be 1. If you put the formula p of x is single message, it is equal to 1. So you will get h of x is equal to 0. The first property, if you are having the single message, so your entropy will be 0. Second, if you are having several messages, but only one message is having the probability of 1 and all other are having the probability of 0, again your entropy will be 0. Okay. Similarly, your entropy, minimum entropy value will be 0 and maximum it will log 2 base of m. M matlab number of messages, number of symbols. Next, h of x is always non-negative. H of x value will be greater than or equal to 0. So these are the properties of what? Entropy, that you can understand here. Now example 1, I am taking the binary channel. If I am taking the binary channel, okay. So in binary we know two binary sources are there, 1 and 0. If one probability is p, one symbol probability is p, then another probability symbol will be 1 minus p. Now I am applying the formula of h here. What? क्या हो जाएगा? h is minus p log p plus 1 minus p log 1 minus p. Now I am interested here to get its maximum value of entropy. So we know for maxima generally we have to differentiate that first differentiation, second differentiation is equal to 0. So next here dh by dp is equal to I am putting for getting the maximum value of entropy. Okay. So if I solve this, then I will get p is equal to 1 upon 2. So p is equal to 0.5, our entropy will be maximum. Okay. So in binary signal, binary source, you will get the entropy maximum is equal to 1 at p is equal to 0.5. Okay. So in this graph also you can understand here. Okay. So the entropy with the probability will increase and it is equal to 1 or maximum whenever your p is equal to what? 1 by 2, and again it exponentially decreases. Yes. Now in example 2, what? An information source generates 4 messages M1, M2, M3, M4 with probability 1 by 8, 1 by 2, 1 by 8, 1 by 8, 1 by 4 respectively. Determine the entropy of them. It's very simple. You know the formula. What the formula? H of this is equal to what? Minus p log p, p के ले लो, this one, base of 2, okay. Now k 1 से कितने मैसेज है? 4. Now only you have to put the value here. You can use this formula or this formula, k 1 to 4, what? pk into log of 1 by pk. This is also you can use. Okay. And you will get the entropy of the source. And remember always what? Base of log is always what? 2. So you have to solve on the base of 10 and at the last you have to divide the term, overall term by 0.3010. Or you can take log of base e for all, but at the last overall term by divide by the 0.693. This you have to keep in your mind. Next, information rate of information or speed of data, communication speed of sending the data in BPS, MBPS, KBPS and so on. So rate of information denoted by the capital R and it is equal to, capital R is equal to small r into h. So it is the product of what? Entropy and rate of sending messages. Small r is the rate of sending messages and h is the entropy and it is bits per second. Now I am taking another example, like an analog signal that is band limited to 3.4 kilohertz sample and quantized into 256 quantized level. During sampling, a guard band of 1.2 kilohertz is maintained. Determine entropy and information rate. So here what? any band limited signal that is sampled to particular frequency. Further, it will be quantized into the some particular level, okay. And some guard band also is given to you. Determine, you have to determine entropy and information rate, this capital R. So at first entropy you have to calculate. So you know 256 level quantization level here, and if these quantization levels, so these are equiprobable, then P is equal to 1 upon 256. If I am taking the entropy, so here what, 256 into 1 upon 250 into log of Pk into log Pk. So this is 256 और सबकी कितनी, एक की कितनी, 1 by 2, log of 2 256. So this is 1, log of 2 to the power 8, then n log m to the power n is equal to n log m. If you this, then you will get 8 bits per sample. So this is our entropy. Now I have to calculate what, capital R. So capital R कैसे निकालोगे? So from the Nyquist criteria we know 2 into 3.4 plus 1.2 is guard band. So this is what, for small r. What? Because Nyquist said we know band limited to 3.4 kilohertz. So 2 into 3.4 plus guard band. So 8 kilohertz or 8 kilo samples per second. Now information rate H into is capital H into R. So I am putting the value. So you will get 64 kbps. So in this way, in these small examples, you can determine the entropy, information rate and so on parameters for any communication channel. Now, of the concept of entropies and mutual information. So entropies I am telling or we are studying here in terms of communications. This is very, very important. In communication, we know 3 things are important: transmitter, receiver and channel. So if I am taking the random variable of x for transmitter and random variable of y for receiver, this one. So we know for the transmitter some source symbols are there and their probability will be that is P of x. So probability matrix for x random variable related to transmitter. Similarly, P of y, this is the probability of receiver symbol of messages related with receiver of random variable y. If P of x is there, we know, if I know the probabilities of the source messages or symbols, I can calculate entropy easily. So if I know the P of x, then H of x I am easily calculate. Then H of y also I can calculate easily, H of y. So these are the individual entropy of random variable x for transmitter, H of y individual entropy of y concerned to receiver. Now if I combine x and y, so this will be the 2-dimensional matrix. So P of x y, this is the joint probability matrix, and corresponding to H of x y, this is a joint entropy we can calculate. Now P y by x, this is what? Conditional probability matrix, and corresponding to H y by conditional entropy we can measure. Similarly, P x upon y, conditional entropy H x upon y. So P x y, this and H x y is the joint entropy whenever you combine x and y, both random variables. H y by x is the conditional entropy. It means entropy of y with respect to x, or entropy of receiver when x was transmitted. This is the condition, and this is very, very important. H y by x and P y, this is the channel matrix or physically possible this thing. P y by x, probability of receiver when x was transmitted. So this is in the channel communication channel matrix we can represent by this P of y, and H of y of x is the its corresponding conditional entropy. P x upon y and H, P x upon y means this is another conditional matrix, probability matrix, and this is another conditional entropy. And x upon y, probability of x, probability with respect to y, or probability of transmitter with respect to receiver. So this is not feasible thing. So generally this type of conditional entropy shows the loss in the channel, loss in channel, or data loss into the channel, we can represent, we can show by Hx upon y. So, these are the different entropies that you have to understand here. Some numerical also I can tell you, but due to the short time. Okay. So, joint entropy, so some formula of joint entropy will be there, this one. Okay. So, joint entropy, whenever you will be able to calculate joint entropy whenever you have Pxy, joint probability matrix. If you are having the joint probability matrix, you can easily calculate H of xy. Okay, then conditional entropies formula, this one you have to, and this is the what? The relation between the different entropies. What? Hxy is equal to Hy plus Hx upon y, or is equal to Hx plus Hy by x. This is the chain rule and shows the relation between the joint and conditional entropy. Okay, and some numericals also I can tell you. Now, again in this lecture, I am trying to tell you about the concepts. So, these were the different entropies related with communication system, individual entropy and combined entropies. Now, I will tell you mutual information. Mutual information means the transfer information between the transmitter and receiver, shared information. So, it is what measures the amount of information that can be obtained about the one random variable by observing the another. Okay. So, mutual information we can give by I of xy between the x and y random variable. Okay. And Ixy we can show by the entropy Hx minus Hx upon y, or Hy minus Hy by x. And these are the properties of mutual, because it depends upon the information entropy. So, its value always positive, it shows the commutative law, and this is the relation mutual information and different entropy. So, mutual information means transferred information between the x and y random variable through a channel for a communication system. Now, using the Venn diagram also we can understand here what is the meaning of mutual information. So, this overlapping part, it shows the mutual information between the x and y. Now, these are the some numericals that you can also solve. So, in this unit, after the information theory, coding will be there. So, at first source coding will be there, source coding. So, after the information entropy, you have to encode your information or source data in terms of some encoder. So, if you use the encoding, source encoding with data compression, so generally in your syllabus, in this syllabus digital communication, you can study, you will study about the Huffman and Shannon phenocoding. These methods are very important and simple and used in digital communication for source encoding, and it reduces the transmission time, storage space, translation table space, encoding and decoding time. Okay. So, in this way we can prefer the source encoding for the information messages that we communicated from the transmitter in digital communication system. So, in this lecture I told you about the information theory, and further in this unit coding part also will be there. That's also very important for us. Okay. So, I think or I hope that now you will be able to understand about the information theory, okay, in communication system. In between my lecture, some examples also I display. Thank you very much.